again, yucky numbers, we don't like them. So what do we have to do to get our nice little y values of 1, 2, 3, and 4? What can we do to get those? Well, to get 1, we need to have 1 under the square root, because the square root of 1 is 1. So what do we have to take half of so that we get 1? Well, it's 2. So if you take a half of 2, you get 1, and then the square root of 1 is 1. All right, so what about to get to 2? Okay, so I want a 4 under the square root, so that when I square root it, I get 2. Well, this needs to be an 8 then, because half of 8 is 4, and the square root of 4 is 2. Okay, now I want the result 3. So to get the result 3, I need to take square root 9. So half of what equals 9? Half of 18 equals 9. Okay? And then to get the result 4, I need a 16 under the square root, because square root of 16 is 4. So half of what is 16? 32. Okay? If you have trouble understanding this, then put these x values into this function, and you'll see that you do get out the y values I chose. Okay? So now let's compare again. This point, this point, this point, and these 2 points with our original. Okay, what do you notice? So for the same y values, how do the x values compare? Well, they're double, right? To get the y value of 1, I have a 2 now instead of a 1. To get the 2, I have an 8 instead of a 4. To get to 3, I have an 18 instead of a 9. To get to 4, I have a 32 instead of a 16. So what does this look like? Well, here I had 1, 1. Now it's going to be 2, 1. 2, 1. Here I had 4, 2. Now it's going to be 8, 2. Okay, here I had 9, 3. Now it's going to be 18, 3. So I don't even know if I have room for this, because it's 10, 11, 12, 13, 14, 16. So 17, 18. Let's go out. You can make 2 more. Okay, and I'm not even going to try the 32. So okay, so I labeled it with the equation. So look what's happening here, okay? Now, I'm not looking vertically, I'm looking at how the changes happen horizontally. It's like I took all of these x values and I pulled them out to be twice as far out as they used to be. So this is a horizontal stretch by a factor of 2. All of these x values are 2 times as big as they used to be. So from 1 to 2, from 4 to 8, from 9 to 18. Okay, I'm stretching horizontally all of these x values by 2. And that's what's happening with this k of a half. Whereas here, I was compressing them vertically by a half. So all of these were a half of where they used to be. So notice, for the same values, for the same number a half, that it stays a half. That means a compression for A. But for the horizontal, for K, it does the opposite. So instead of compressing by a half, it stretches by 2. Okay? So that leads us to our summary of what you hopefully knew. Now, if you are completely confused up to this point, you just kind of make sure you copy down the summary and memorize it, okay? The least you can do is memorize what K does. What you just saw was my attempt to try to explain to you why K does what it does. And that's important if you're continuing in the mathematics stream or engineering science or whatever, to understand the why behind it. And also, of course, for communication questions, to show critical thinking, it's important that you understand. But this is way over your head right now. Don't panic too much. The rest of the note, we're going to be doing some examples. I'm going to do a summary, and hopefully after playing with this a little bit, you can re-watch what I just did, and hopefully it'll make more sense once you've actually worked with some graphs and with some numbers. Okay? And that's why I'm hoping that these videos will help you, because you can re-watch explanations that I'm doing for you. So this is really the important part of the note, this summary. So this is what k does. So notice I have absolute value signs here because I'm just looking at the value of k, not the fact of it if it's positive or negative. So just like the value of k. So if k is greater than 1, then that is actually a compression, okay? That means it's compressed horizontally by 1 over k. So for example, if your k value is 4, then that means that all of the x values are going to be a quarter of where they used to be. So that's why I have this arrow here to show that it's being compressed horizontally in this direction. Okay, so you compress everything in. All your x, you're not moving them up and down based on k, you're moving them left and compressing them. But if your k value is between 0 and 1, then that's actually a stretch. So the graph is stretched horizontally by 1 over k. So if your k value is 1 over 3, then that means everything's being stretched out by, instead of 1 over 3, 3 over 1. So by 3. So all the x values are 3 times as far out as they used to be. That's why I have the arrow this way. Now when k is less than 0, the graph is reflected on the y-axis. So the arrows go this way because it's reflected this way. Now sometimes people say y-axis and they think y and that's vertical and they go this way, but no, that's the y-axis. It's a horizontal reflection. If you want to write a horizontal reflection, that's what it is. So if the point x, y is on f at x, then the point x over k, comma y, is on g at x equals f at kx. So what do I mean by that? Well, if you have the 0.65 on your original function, then if your new function is f at 3x, that means your k value is equal to 3. So that means your y value stays the same, see, y. But now your x value is just divided by k. So 6 divided by 3 is 2. Okay, in this example, k is equal to 1/3. Okay, so our y value stays the same, but our x value is being divided by 1/3. Okay, another way of thinking about being divided by 1/3 is being multiplied by 3. Okay, so dividing by 1/3 is the same as multiplying by 3. Or you can just use your calculator. 1 divided by 1/3, you get 3. Okay, now what about this? Our k value here is 3 over 2. Okay, so the 7 is staying there, the y value. So 2 is being divided by 3 over 2. Okay, just remember your fraction rules, people. Okay, this just means 2 times 2 over 3. Okay, so you get 4/3. So remember, division by a fraction is just multiplication by its reciprocal. So I really want you to make sure you understand this part here. It's going to be very crucial going forward. So if you need to, you can pause it and really go over that. Okay, so on the next page, we'll get to the examples. Consolidate this a bit further. Okay, so we're going to identify the parent function and then transform using our k value. Okay, so in this case, the parent function is x squared. I kind of wrote that for you already. So let's just write the 5 main points of a parabola. So 0, 0, 1, 1, 2, 4. Okay, so when I say 5 main points of a parabola, that's what I mean. You guys should know that from last year. Okay, so there's your y equals x squared. Okay, so minus 2, 4, minus 1, 1, 0, 0, 1, 1, and 2, 4. Okay, those are the 5 main points of our parabola. Just making sure you can see those there. Yeah, you can see them. There you go. There you go. Okay, so now you can think about this graphically or you can think about it algebraically. So when we are, our k value here is 4. Okay, our k value is 4. So what does that mean? That means that it's being a horizontal compression by a quarter. That's what that means. That means that all of these x values are going to be a quarter of how far out they are now. So I'm going to show it graphically first, and then I'll do it with the points. And then the other one I'll do the opposite. So 0, 0, it's a quarter as far out as it was. So I mean, it's still just 0, 0, okay? Now 1, 1, instead of being out 1, it's a quarter of that. So we're at a quarter 1. Okay? And instead of being out 2 here, we're at a quarter of the way, so that's a half. Okay, and since this is symmetrical, we could say the same thing for on the other side of the y-axis, okay? So instead of -2, we're only out -a half. So there, you've transformed, oops, it's really, let me do that better for you there. Transformed the 5 key points, and that's enough for a parabola. So you can see it's being compressed horizontally, or being squished in this way. So if you're looking at the coordinates, remember that you do x over k and y. So all the y values are same, but all of the x values are just being divided by your k value, which is 4. So -2 over 4 is -1/2. Your y value stays the same. -1 over 4, 0, 0 doesn't change. 1 over 4, same y value. 2 over 4, which is 1/2, same y value. Okay, and those are the points that I just sketched. Okay, so that's kind of if you're more of a visual person. Now, alternatively, you can do the coordinates first and then just plot them where they're supposed to go and then see if it visually makes sense. So let's do 1/3 x here. So this means that k is equal to 1/3. So that is a horizontal stretch by 3. Okay, because remember it's 1 over k. So 1 divided by 1/3 is 3. So all the k values are going to be multiplied by, all the x values are going to be multiplied by 3. So that was the one we just did. This was y equals 4x all squared. So now we're going to do this one here. So all of the x values are being divided by 1/3, or again, an easier way of thinking about that is just multiplied by 3. So -2 times 3 is -6, -3, 1, 0, 0, 3, 1, and 6, 4. So let's just plot those points. So -6, 4, -3, 1, 0, 0, 3, 1, and 6, 4. Okay, so those are our coordinates. I'll do it in green here. Okay, and that's y equals bracket 1/3 x all squared. So what happened here? All of our x values are 3 times further out than they used to be. So instead of here being at 1, it's now at 3. It's 3 times as far out. And instead of being at 2, it's at 6. So it's 3 times, it's stretched horizontally 3 times. So it's like you took these and stretched it out by a factor of 3. Okay, one more example. So for any of the parent functions, the best thing to do is to start with, let's say 5 or 6 of the key points from that parent function, the key points you would use to plot the parent function, and then you just take those points and transform them. Okay, example 2, I threw in here a d value of -3. Okay, so in this case, y equals 1 over x is the parent function. That's the parent. And you'll notice here, I went from here to here because the k actually, and we'll talk more about this next lesson, but the k here has to be factored out to show the d properly. So your k value here is just -1, and your d value is -3. So this 1 over x is going to be reflected horizontally, so this way on the y-axis, and then moved to the left 3. That's what's going to happen here. So first let's draw our 1 over x. So the points I always use are -2 minus a half, -1 minus 1, minus a half, comma, -2, and then an asymptote at x equals 0, okay, or vertical asymptote. Then we have a half, 2, 1, 1, and 2 a half. So let's draw that. So we have x equals 0 as a horizontal asymptote, vertical, y equals 0 as a horizontal, and then you plot these points. So 2, -1/2.